And the tool here to cross the bridge between Kotlin and Swift is called Objective-C. Whenever you compile your KMP code, it's compiled by Conan, the Kotlin native compiler. And at the end of compilation, it will export an Objective-C framework. Then Xcode will bridge your Objective-C framework to Swift. So pay attention here. That's where all the problems reside. Because if there's a feature that's available in Kotlin, you have a similar feature in Swift, but that feature is missing for Objective-C, that feature will be missing translation. But then you can ask me, why Objective-C? Why doesn't Conan just export a Swift framework? Okay, first, a disclaimer. My presentation, comments, opinions are provided in my personal capacity, not as a representative of Walmart. They do not reflect the views of Walmart and not endorsed by Walmart. So, hi everyone, salve a tutti, I'm Andrea Orieni. Io sono italo-brasiliano, perciò questo accento un po' diverso. I'm a Brazilian with Italian roots, Lombardy Veneto. I work at Android since the very first public release because at that time I was at Motorola, so I helped them develop their very first Android device, including the famous Droid series. And I'm currently a tech lead at Walmart in California, right? So if there is any slide you want to take a screenshot, this is the one. This whole presentation was based on a series of articles I wrote about KMP and Swift, so all the content is there, okay? Okay, so let's get started. Kotlin Multiplatform is awesome. Now if you know a little bit of Compose, Ktor, SQLite, and other KMP libraries, you can write an Android app, an iOS app, a web app, and even a desktop app from the same code base, right? However, in order to accomplish our secret goal of complete domination of the world of mobile development, we need to bring the iOS developers to our side. And how can we accomplish that? We can do that by writing KMP libraries that are so good, they won't even know they were written in Kotlin. And that's what this whole presentation is about, how to write KMP libraries that play nice with Swift, right? So, but you can ask me, Andre, Kotlin and Swift are so similar, right? So why is it so hard to write KMP libraries that are good for Swift developers? Okay, if you're ever going to visit me in California and you try to cross the Golden Gate Bridge, you're going to discover you're going to have to pay a toll. And the toll here to cross the bridge between Kotlin and Swift is called Objective-C. So whenever you compile your KMP code, it's compiled by Conan, the Kotlin native compiler. And at the end of compilation, it will export an Objective-C framework. Then Xcode will bridge your Objective-C framework to Swift. So pay attention here. Xcode is actually expose your KMP code to Swift through this work of bridging between Objective-C and Swift. So that's where all the problems reside. Because if there's a feature that's available in Kotlin but is missing, but is available in Kotlin, you have a similar feature in Swift, but that feature is missing for Objective-C, that feature will be missing translation. Right? But then you can ask me, why Objective-C? Why doesn't Conan just export a Swift framework? So there's many reasons for that. The main one is the binary interface for Swift only became stable quite recently, whereas Objective-C one has been stable for years, right? So this is going to be the format of my presentation. So first I'm going to propose you some Kotlin API. Then I'm going to show how the APIs export to Objective-C. And finally, I'm going to show some client code trying to use the exported API. But as you can see from this slide, Objective-C is quite hard to read. It's pretty verbose, right? So I'm going to provide you the translated version to Swift, right? So much cleaner, much easier to read, right? So pay attention to the icons. So Kotlin icon for the KMP API, Swift origin icon for the Swift exported interface, and Swift UI blue for the client code. So the first problem we're going to talk about is name clashing. Whenever you see extra underscores in your exported Swift API because some name clash happened. Well, what did happen if everything was fine on the Kotlin side? So they happen for two main reasons. So first, Kotlin has multiple levels of namespace because you can always net packages. But Swift only has one level namespace that's exported framework, and Objective-C doesn't support namespace at all. So when you compile your code, all your classes in KMP will fall in the same namespace. So if they have similar names, they will clash, even though they're in different packages, right? Another reason is that whereas in Kotlin, the method signature is the method name plus the parameter types, the method signature in Objective-C in Swift is the method name plus the parameter names. So if you have multiple overloads of the same function in Kotlin, and they always the same parameter names, they will clash as well. So let's see some examples to make things clear. Right? So here we have two classes that share the same name, item. They are defined in different packages, network model. Because they have the same name, they will clash. But Conan, the Kotlin native compiler, tries to intervene here and tries to add a score to one of the classes. But which one, right? So here in this example, item 1 is item from the network package or from the model package. So it's hard to know. So the solution to this is to use the Objective-C name annotation, which allows you to specify the name of the export, the symbol's name in Swift and Objective-C. So here we use the annotation Objective-C name. So we see that in export the Swift API, we have pretty distinct names. So we have item response, item model. So now it's pretty clear for your Swift developer which class is which. Here we have multiple overloads of the same function sort. They all use the same parameter name data, but they use different parameter types. This is okay in Kotlin because the parameter types are distinct, but it's not okay in Swift because the parameter names are the same, and therefore they will clash again. So Conan, again, tries to avoid the clash by adding a score to one of the parameter names, but which one, I don't know. It's completely unpredictable. So again, you can just use Objective-C name annotation here, or you can just use better names, right? So here's a little bit more curious case, because here we have two interfaces, person and robot, and they both define the same field ID, but they use different parameter types, right? In Kotlin, it would be impossible to have an Android class that implement both interfaces because the compiler would complain that you have conflicting definitions for ID because they use different types. However, it's not a problem in KMP because, again, Conan will try to avoid the clash by the score to one of the fields. And then you can have your Android class in Swift. So again, the same solutions apply here. Either you use Objective-C name annotation, or you just rename your fields. So now I'm going to talk about cases in which the type that's used in the exported Swift API is completely different from the one you define in Kotlin. So here we have this interface product, and we have a class consumer with a method consume that takes a set of products. But then when we look to the exported Swift API, we see that, okay, our interface product now became a protocol product because interfaces in Kotlin are mapped to protocols in Objective-C and Swift. Our class consumer is still a class, but we can see now something a little strange or a method consume because now it takes a set of any hashable. Where did those any hashable come from, right? And things get even stranger when you look to the sample code here. You see that we can pass a set of integers. We can pass it to method consume. The code compile because integers, of course, they are hashable. But of course, this is not going to work at the runtime. So what is going on here, right? So whenever you use set in your KMP API, it's going to be mapped to NES set in Objective-C. In Objective-C, then in Objective-C, NES sets are bridged to sets in Swift. And Swift sets require that all elements conform to the hashable protocol, a Swift protocol. The problem is, as already said, interfaces in Kotlin are mapped to protocols in Objective-C. And Objective-C protocols cannot be extended to conform to other protocols, let alone a Swift protocol like hashable. So after type erasure, the type will be set to any hashable because any hashable is the eraser type for hashable protocol. But on the other hand, all KMP class that you define are going to indirectly inherit from NES object, which conforms to the hash protocol. So the solution here is to use classes. So now our our product is abstract class product because in Kotlin, interfaces kind of behave like abstract classes in which every field is abstract, right? Because in the end, the only thing that can implement a protocol, an interface is a class in Kotlin. Whereas in Swift is a little bit different. Protocols, there's many things in Swift that can conform to protocols. You can have like primitive types conform to protocol through extensions. You can have structs, right? But on the other hand, now we can see that our method consume only accepts a set of products. So even if you try again to pass your set of integers, it won't compile. It will only compile if you set the pass of products. Here is another example. We have this inline value class. I don't know how many of you already use inline class. But if you were using inline class in KMP, right? So here we define one postal code and try to define a class that uses that line class. But then when we looked at the export as Swift API, we see that there is no definition for postal code anymore. And later that tries to use our post code inline class, we see now that zip code type is any, which in Swift means anything at all, and not only objects, but can be primitive types, structs, everything. So here I'm passing a UI view controller and a compile fine. For those who don't know, UI view controller is the same thing as a fragment in Android. So the general advice here, don't use inline classes. Use regular classes or just use primitive types or strings. Now I'm going to talk about cases in which the exported API is okay, is usable, but we can make improvements to make it more intuitive to use for Swift developers to use them, right? So here we have this interface person, and we try to define extension full name for that. But then when we look to the exported Swift code, there's something here a little bit different, something that reminds us of trying to use a Kotlin extension from Java, right? So we have this stacked method that whose first parameter is a receiver, right? I don't know about you, but I never like to use extensions like that, and I can guarantee to you that Swift developers won't like it either, because there are also, extensions, a concept that existed in the iOS developed for a very long time. Objective-C has extension. And the problem here is that in Objective-C, you cannot define extensions to protocols, right? So again, the solution here is to use classes. So now we change again our class person to be an abstract class. And you can see now that if you define extension in Kotlin, it will be exported as extension to Swift. So then we have an interface that iOS developers are expecting, and we also are expecting to be able to use extensions like the same way we use in Kotlin, right? Here I have something a little bit more interesting. So we have this method InSInRange that accepts a Kotlin range, right? We can even see example here of the usage in Kotlin. It just passes a Kotlin range. But then when our Swift developer tries to use the same API, it's pretty awkward because they have to create this Kotlin range object here, right? Swift also has ranges, right? Wouldn't it be better if they could just use ranges, right? Like we do in Kotlin? So the trick here is to use this annotation here, should redefine Swift. Your method is still going to be available in Objective-C, but it's going to be hidden from Swift because there's going to be two underscore is going to be perpend to the name. And also, there's some extra annotations of the Objective-C side that make it invisible to Kotlin. So you can see in the first right panel that the method has completely disappeared from the myRange class, right? However, you still can write Swift extension to your myRange class that can take the Swift range, convert to a Kotlin range, and call the original method here. So if you see on the second right panel, that's exactly what I'm doing here. It's a little bit weird to understand because the name has now, the method has two underscores, and because it's only available in Objective-C, it's using Objective-C notation, right? So that's why a little bit strange. So it has the first parameter using range value and the second parameter range. But in the end, our Swift developer has a more intuitive interface because they can just use range like we can do in Kotlin, right? Another thing is that you don't need to define everything in common main. You can have some function that's only specific to a particular platform is not available in the others one. So in this particular case here, we try to define a Ktor extension to the Ktor URL class and convert it to the native type. So in the Android main source code, I'm defined here to convert to Java net URL. But in the iOS main source code, I'm converting to NSURL, and thanks to the bridging between iOS, between Objective-C and Swift, is converted to a URL in Swift. So regarding the flow arguments, I have bad news for you. It's not supporting KMP because guess what? It's not supporting Objective-C, right? So there's a proposal to have something similar to JVM overloads, but until there's two solutions. Either you write overloads by yourself, or you use a library, Sky, made by TouchLab that can generate all the overloads for you. So you can see here in my example, if I try to meet the ignore case parameter, which has a default argument, the code will not compile. Okay, exceptions. Exceptions is a very curious case. I don't know if you guys remember Java. In Java, we have checked and unchecked exceptions, right? So if you have a checked exception, you must either catch it or warn that you may troll by adding this troll clause at the end. Kotlin went away with the checked exceptions, but Swift still kind of have it. So that generates some interesting results. So let's see this example here. So here we have this class bomb with the method explode that's definitely going to throw exception. If we look at the export Swift code, there's nothing different, not unexpected. And we see here that our Swift developer tries to be pretty careful placing this do catch block around the method here, trying to catch exception. However, boom, the method crashes anyway, despite all efforts of our Swift developer to capture the exception. And guess who to blame? Us, Kotlin developer, as is clearly marked by the error message here. Function doesn't have or inherit throws annotation, thus exception isn't propagated from Kotlin to Swift as any error. Okay, so let's add the notation here and see what happens, right? So I add a notation here, and in this slide I must be doing different from all the other slides. In this case here, I must show you what's the exact exported Objective-C interface. So we see here that we add a notation. After compile the code and export Objective-C, we see that it completely changed the method signature. The method now in Objective-C is called explode and return error. And it takes this pointer to any error object. So this is following the convention of the Cocoa libraries, the libraries that like UIKit and Foundation that are used to develop iOS apps. The convention is that if the method can generate an error, its last parameter will be a pointer to an error object. If that pointer is null, the method has succeeded. If not, the method has failed, so you can inspect the error object to try to understand what happened. And when Xcode see Objective-C functions that follow that convention, it will map those functions in Swift to functions that can throw exceptions. So you can see here that in Swift, the method has the original name, explode, but it has this throw clause at the end to make it pretty clear to our Swift developer that that method can throw exception. And now our Swift developer can not only cache the exception that was thrown on the KMP side, but can also use the Kotlin exception extension to recover the original Kotlin extension and be able to better handle the error. Right? So now let's see how Enums and sealed classes are mapped to Swift, right? For Enums, the problem here is that in Objective-C only supports C-style enums, right? I don't know if you ever programmed in C, but C-style enums are enums in which every element of the enum is mapped to an integer constant. It can only map to an integer constant, right? But we can see that Kotlin here tries to do a good effort and try to emulate the Swift enum by creating this class result, right? Inherit from Kotlin enum, and then each element of the enum is now constant instance of the enum class. And I don't know if you guys already play with Swift, but the generate syntax here then and then for the clients to use is pretty similar. I don't know if you guys are used to this dot element notation, but it's pretty useful. But the problem here is because there is no way for Swift to know that the only possibilities of your Enum class are loading success and failure, you're going to have to provide this the useless default clause that's never going to be hit. Because switches in Swift are exhaustible like and when in Kotlin, right? And for sealed class, things are not better. Sealed classes are the closest thing we have from Swift enums, right? Because you can also create, you can define which possible subclasses. You can also pass some data. So that's something that's possible with Kotlin enums, with Swift enums, right? But as you can see in this second left panel here, our Swift developer will have a pretty hard time trying to convert to downcast to the correct class because from the Swift point of view, our sealed class hierarchy is like any other class hierarchy, right? So there is no way for Swift to know, again, that the only possibilities of your class is just results, success, and failure. So again, you're going to have to provide this useless default clause here. So what's the solution here? So if you remember what we did for the range example, right? We see that whenever we have a feature in Kotlin that's similar to a feature in Swift, but that feature is missing from Objective-C, we're going to have to write some Swift code to cover that gap. And that's exactly what I do here, right? So we create the Swift enum that will replace our Swift enum or Kotlin enum or sealed class hierarchy, right? And then two of the things that, the craziest thing that I learned about Swift. So in Swift, you can write the extension that add constructor to a class. And that constructor can return null. Two things are completely unthinkable in Kotlin, but are possible in Swift. So here I'm just writing, through extension, I'm writing a constructor for our Swift enum, right? That basically converts our enum class, Kotlin enum class, or Kotlin sealed class hierarchy to the Swift enum. And then if we give a Swift enum to a Swift developer, for them it's business as usual, right? But then you ask me, Andre, do I have to learn Swift? Will I have to write the Swift or wrapper enum for every Kotlin enum that I have, for every sealed class that I have? No, there's already libraries that can deal that for you and generate this wrapper enum for you. So namely Mocha K-Swift and TouchLab Sky. Now let's talk about generics. Generics were not supported by Objective-C until 2015 when Apple introduced lightweight generics to improve the interoperability between Objective-C collections and Swift collections, right? So before lightweight generic, your Swift developer would define any SRE, but will not be able to tell what that SRE contains, right? You'll not be able to say, for instance, this is an SRE of integers. So then when that code was then used by the Swift developer, the only thing he or she would see it was a list of any. And then they would have the trouble of casting this any to the, forcibly casting to the correct type, right? But now, and the same thing, similar thing for the other collections you have Objective-C. So any S dictionaries would be mapped to a dictionary of any hashable to any in Swift. And as we already see in the beginning of this presentation, any S sets are mapped to a set of the any hashables, right? So now, after lightweight generics, or Objective-C developer can define what the NSRA is about. So in this particular first example here, we can say that N is an NSRA of the NSRL, and that's nicely mapped then to a list of URLs in Swift, right? But because generics in Objective-C were only introduced to solve this particular problem, they're only supported by classes. So let's see some examples to make it more clear. So here we have this interface cat, right? But interfaces export to protocols, and protocols do not support generics. So our data field here is going to be of type any, right? Because generics are not supported. It is going to be any nullable because there's no way for Conan to know that the type you are passing is nullable or not. The only thing you can do is you try to bound to any to say that's certainly not nullable. For classes, everything seems okay because if you have a generic class in Kotlin, it will be a generic class in Swift. The only thing interesting here is when you try to define bounds. So in this case here in the bird class, we try to bound the generic type T to number, which is a Java class from the standard library. You see that that bound is not, is completely ignored. It's still bound to any object like, or simple generic class dog, right? So bounds in any object, for those who don't know Swift, is just a pointer to an object. The same way that any is a pointer to object in Kotlin, or object is a pointer to object in Java, right? So bounds are not respected. Methods and functions also do not support generic, but there's interesting things that happen when we set the bounds to a type that was defined by us. So you can see in it, right? So T is bound to number, which is a class from the Java standard library. So it was defined by Java, not by us. We can see that the parameter name on the other side of the export to Swift API is any. So the bound was completely ignored. But for drink, I'm set the bound to my interface that you can see on the top was the type that was defined by us. And we can see that in drink, the argument now is my interface. So there's no support to generic, but there's some type erasure respecting the bound. Now let's talk about flow and coroutines, right? So whenever you have a suspend function in Kotlin, it will be mapped to a function with completion handler and Objective-C. Completion handler is just another fancy name that Apple gave to callbacks, right? And since it's version 5.5, Swift supports async functions. And after that, then whenever Xcode see an Objective-C function with completion handler, it will be mapped to async function. So that's why here on the Swift interface, we have two generate functions, right? The first one is the original one from Objective-C that used completion handler. And the other one is using the sync version, right? So I'm not going to show you how to use the callback ones because I don't think anyone likes callbacks, right? No one wants to create a parm of doom here. So I'm going to show you how to use async functions in Swift. So it's pretty similar to use coroutines in Kotlin, right? We had to create a task, pretty similar to create a coroutine scope, a job in Kotlin, right? We can set this main actor that's kinda, but not exactly the same things as set the main dispatcher. If I say there's the same things, I know that some Swift developer will be pretty mad at me. It's not the same thing. You have to use this await keyword to call the async function, which is pretty similar for us using launch and await to call suspend function. The only problem though is that if you try to cancel the task, your coroutine will not be canceled because remember, this sync version here was generated by Xcode, which has no idea that you are using Kotlin coroutines, right? So cancel the task won't cancel your coroutine. And things for flow are not even better because flow, shared flow, state flow, they all are interfaces. And we just learned that interfaces do not support generics in KMP. So your Swift developer will know that they got the flow, but they have no idea what that flow is about. They completely lost the type information. They don't know there's a flow in each, right? So how can we solve this issue, right? It's kind of hard because you have to write some Kotlin code and Swift code, but fortunately there's already people that work on this problem and provide solutions, right? So there's several libraries for that. There's Skype by TouchLab that solves this issue, but the one I'm going to be talking about here is KMP-NativeCouroutines, which recently received a grant from the Kotlin Foundation, right? So using KMP-NativeCouroutines is pretty simple. All you need to do in the Kotlin side is that for the scope that you want to use with Swift, you just need to annotate with native coroutine scope, right? And then you just need to annotate every suspend function in flow with native coroutine annotation. And then for your service developer to use, things are going to be pretty similar, just only small changes, right? So the first small change here is that they're going to have to import this KMP-NativeCouroutine async framework, right? And then the only thing they need to do that's different, they need to call a sync function to call your suspend method, right? because this async function will establish the connection between the Kotlin's, the Swift task and the Kotlin coroutine. So when you cancel your Swift task, that cancellation will be propagated to the KMP side and will cancel your coroutine. For flows, there's many possibilities, right? One of the possibilities is to convert your flow to Rx Swift, but in the same way we're moving from Rx Java to Flow in coroutines, Swift developers are moved from Rx Swift to combine with a publish and subscribe protocol created by Apple, right? So I'm showing here how to convert our flows to combine. So again, the only change they need to do here is that they need to import the KMP native framework, and then they just need to call create publisher to convert the flow into a publisher, right? I don't know if you guys already play with this, but then the only thing that then after they create a publish, the only thing the Swift developer has to do is eventually call sync, which is pretty similar to subscribe or in RxJava or collect in coroutines, right? And the good news here is that when you cancel your publisher, you also cancel your flow. And that's all. If you find everything here too much complicated, you just use Compose Multiplatform. Then you can write the entire iOS app just using Kotlin. You don't have to worry about Swift or Swift developers. Okay, so I'd like to thank all those folks here for helping me writing my articles and also helping promote them. And now I'm open to questions.